Hey, so now we're going to talk about adding the forces together. If we take a look back at Wikipedia and we go down to the first law, in mathematical terms, it says that if the sum of the forces, the vector sum of the forces is zero, i.e. the forces balance, then there's no change in velocity. So we need to check and see that the sum of the forces is zero. We're also laying the foundation for multiple forces on our object. So this is a challenge video. What I'd like you to do is using systems.collections.generic at the very top, that'll give you access to a list, something of type list. So I want you to create a public list of forces, call it force vector list. Create an add forces method, which will step through that force vector list, adding up all the forces. Then I want you to log an error to the console if we have a net force. Otherwise, just continue to update the position. So it doesn't matter how many forces there are on the thing, if they all precisely balance out, great. The object will just continue to be at rest or move in a uniform state of motion, as the first law says. Otherwise, we're going to log an error. We don't know what to do yet if there's an unbalanced force on it. So go ahead, have a go with that, and I shall show you how I do it in just a moment. Okay, welcome back. So here we go. I'm going to make a couple more publicly exposed variables up here. I'm going to go public, vector3, net force vector like that, which is going to be my net force. And I'm also going to have another public list of type vector3. Now, you're going to get a red until you're using system.collections.generic. Now the list will work. So I want a public list of type vector3 called force vector list, and I'm going to initialize it with a new list of vector3s, empty list. Great, okay, so I have a force vector list now. Let's just take a look at it over in the inspector. It's going to work already. It's not going to do anything, but it's going to be there. Here we go, force vector list. If I made that of size 2 or 20, whatever 2, then I could have one force with 1, 1, 1 and one with 0, 0, 0, and it's not going to do anything, but you can see that you have the facility now to add multiple forces, as many forces as you like to this thing, which is fantastic. So moving on, we have created a public list of force vectors. Let's create an add forces method. Let's go ahead and do that right now. It doesn't need to return anything because we're going to update the instance variable net force vector directly. Okay. But at the start of each of these add forces, every time we call add forces, we're going to want to set the net force vector to 0. And the easiest way to do that is vector3.0, because we're going to start afresh each time. So on each fixed update, we add forces, and then we update the position. So then we need to do something like this for each. Vector3 force vector in force vector list. So that's the for each loop. So for each force vector of type vector3 in the force vector list, the net force vector plus equals, so equals itself plus, I'll just write it out in full, equals net force vector plus the force vector we just looked at. So that just goes through, however big or small this list is, adds them all together and gives us a result. Now what we need to do is the final bit of the test, which is this. I said we want to debug.log error if we have a net force, because we don't know what to do with it yet. So I'm going to do that up here in my fixed update. I'm going to add the forces together and then say if net force vector equals vector3 dot 0. So if there's no net force, then let's go ahead and update the position as we did before. But now, if there is a net force, then what do we want to do? We want to debug.log error, something like unbalanced, force detected, help. And of course, we'll sort that out later with Newton's second law. Get rid of a few spaces, tidy the code up, make sure we understand what's happening. Every frame we add together the forces. If they are 0, if there's no net force, we carry on in confidence with Newton's first law. updating the position. It's this constant velocity movement, basically. The only thing that may change is time.delta time, but this will take care of it. Otherwise, we log an error. Let's see this working. Let's start off with no forces in the force vector list there. Hit play. The ball is stationary, there are no errors being logged, and there's no change in position. Fine. Now let's add a force. Let's add an array of 2, 1 in the x direction. Now what's happening? It's not moving. Great, our code is not moving it because it doesn't know what to do with this unbalanced force. And it has a net force of 1 in x. If I put -1 in x, in addition, now the ball does not have an unbalanced force on it. It is just completely balanced. There is no net force on the ball. So at this point, we should be seeing the ball moving. Why aren't we seeing it moving? Because it has no velocity. You see, at the moment, this thing is only staying at rest or moving with constant velocity. So let's give it some velocity, say 10, off it goes. Let's take away, or add a third force maybe. Let's add a third force of 0, 1, 0, maybe in y. Now it stops moving altogether, just stops dead, because the engine says, I don't know what to do. I have an unbalanced force. I have some y component. So I'm just going to stop. Now your challenge is add one more force now under element 3 to stop the force being imbalanced. What are you going to put under element 3 to make the force balanced? Very simple. Go ahead and do that now. Proof of the pudding will be the ball starts moving again. So it's y equals -1, right? So at y equals -1, both of these forces balance. The 2x forces balance and the 2y forces balance. Fantastic. So we now have an engine that pretty much fully explains Newton's, or models Newton's first law. He says when viewed in an inertial reference frame, we have, that's Unity's global coordinates, an object either remains at rest or continues to move at constant velocity unless acted on by an external force. It really means an unbalanced external force, as explained down here. So finally, to help you visualize all these different forces you're adding to the ball and really see how they balance each other, I've got a handy little script for you. If we go to Import Package, Custom Package again, reopen your Section Unity package, and select this time just the drawforces.cs. Now, if you have any errors, it's probably because your physics engine, either your physics engine file is not spelt exactly like this, or if you go into physics engine, you need to make sure your class is exactly physics engine. Because at the top of draw forces, which I'm not going to take you through how it works, it just draws some lines, but at the top of it, it says requires component physics engine. And it's expecting there to be a physics engine with a list of forces on it. Okay, but what does it do? Well, drag it to the ball and let's take a look. Now let's give the ball, say let's give it 3 forces, space for 3 forces. Maybe we have a force that's 2 in x, 2 in z, something like that. Click play. And you see that you have the vector there. Cool. Now let's have a force that, I don't know, 2 in y and 4 in z. Oh, there you go, you have another force. Cool. How about we have a third force, which is, I don't know, maybe 3 in x and, I don't know, 4 in y. There you go, 3 different forces on that ball now. And you can see that between the 3 of them, they're going to be, they're like thrusters. The length of the arrow is proportional to the amount of force, and the direction is going to be away from the ball, so it's like thrust is coming out of the ball, like it's ejecting mass. So that ball would be accelerating to the left on the screen at the moment. And it has a resultant net force vector of 5, 6, 6, as you can see here, and it's not moving anywhere. So if we add one final force to it, with a magnitude of -5, -6, -6, then we end up with a net force of 0. We have no more errors being logged in the console. And if we were to give it a velocity, any velocity in any directions, it will just move along happily. That's pretty cool, hey? You can see the forces balancing. It's got one big thruster firing off to the right there, sending the ball to the left, and it's got 3 other thrusters that are all balancing each other out. Pretty cool. So that's a useful little script. If you want to turn those trails off, the best way to do it is just to either remove the component altogether or to untick the show trails checkbox, and the line renderer will then go off. You can collapse this line renderer down if it's messy for you, so that you just have trails or no trails. And however big or small your list gets of forces here, this thing will update dynamically if you add a third, etc. So pretty cool. Have fun. Have a play with this. Try and get used to what these force vectors look like, what that means in X, Y, and Z, and enjoy it. If you want to be able to see Unity's X, Y, Z coordinate systems as well at the same time, then perhaps you should give it no velocity, and then just go over into the scene view. The thing will be sitting at the origin, and then you can compare the forces you're adding to the XYZ gizmo over here. So for instance, if I have just a 2-2 force, you can see a 2 force in the X direction, you can see there, a 2 force in the Y direction, a 4 force in the Z direction. You see how that's working, and now you get the coordinate axes to visualize this with as well. Okay, you'll still get your unbalanced force warnings. It's going to be the same as the game view, it's just that as soon as the ball starts moving, it's going to disappear off the screen eventually. So provided it's got no net force. If it has a net force, the code is keeping it stationary for now. So that's it. Cool. We can add forces. We can make sure they all balance. If they don't balance, we leave the thing still right where it is because we don't know what to do. And if they do balance, then off we go. So pretty cool, right?